Okay. We are going to start. This is weird looking right now, but finite first section is section 1.4, which is intersection of straight lines, which hopefully is going to be a review for you. So first question is, how do we write the equation of a straight line? So straight lines are linear, right? Linear, we often think of y equals mx plus b, where this is our slope and where oh, this is not working so well. And where this is our y-intercept. And I seem to have messed something up because it won't even work now. Hooray! I was trying to get to this, where this is our y-intercept. Hopefully that is all good still. If you don't have slope-intercept form, remember that you have point-slope form, where if you have a point and a slope, right, the point on the line is the point x1, y1, and again, where m is your slope, okay? Linear equations show up all the time. How do we find the intersection of two straight lines? Well, hopefully, if you have them graphed, you know that the intersection of two straight lines is just going to be the point where they cross, right? And so graphing is one way that we can do that. Do you remember any other ways? Well, we learned 3 ways in our previous classes that you can solve by graphing. But if graphing doesn't work so well algebraically, you can do it by substitution or by elimination. And that's what we're going to try to figure out today. Okay? So let's just look at an example. It says, find the point of intersection of the straight lines that have equations y equals x plus 1 and y equals negative 2x plus 4. So very nicely, these are already in slope-intercept form. So if I'm going to graph y equals x plus 1, maybe someday my computer will be fixed. Well, that doesn't work well. I'm going to start with my y-intercept, right? That's a point on my graph on the y-axis. So I'm going to go on the y-axis to 1, and then I'm going to do my slope, which is the number here. Rise over run, or the rate of change is up 1 over 1, up 1 over 1, right? Hopefully we feel good about this. And if I graph negative 2x plus 4, my y-intercept is up here on the y-axis at the point 4, 0. So that would be like 1, 2, 3, 4. And my slope is negative 2. So that means down 2 over positive 1. Or you can go up 2 and left positive 1. Again, straight line. Where do they cross? Well, we can see right here that they cross at the ordered pair 1, 2, right? Graphically. But if we do the same thing, but I ask you to do substitution. What does substitution mean? Substitution means you substitute one variable in for the other. And these are really great because they both equal y. So if y equals x plus 1, that means I can substitute it in right here. So I would get x plus 1 equals negative 2x plus 4. And then I'm just going to solve that equation, right? We talked about yesterday, solving the equation means finding the point that makes it true. So that means I want to get my x's on the same side. So for me, that means I'm going to add my 2x over here. And at the same time, I want to move the 1 over here. So to undo adding 1, I'm going to subtract 1. And I'm going to get 3x equals 3. Divide by 3, and I get x equals 1. But remember, I'm finding the solution, so that's not the whole solution. We already know because we graphed it first, is I have to find the y that goes with it. So to find its mate, you just plug that back in to either one of those equations because it should work in both of them, right? So we would get 2, y equals 2, and x equals 1, which means they cross at the ordered pair 1, 2. And if you plug that in for this one, you still get 2 for the y value. And then the third way of doing this is elimination. So elimination is when you eliminate one of the variables. So again, you just kind of want to match them up. So I'm going to just rewrite them like this. Y equals x plus 1 and y equals negative 2x plus 4. Oftentimes you put the x and y on the same side, but we could do this. If we wanted to eliminate the y's, remember you can add or subtract. In this case, I'm going to subtract everything. So y minus y, that eliminates and that leaves nothing. 1x minus negative 2x, that becomes plus 2x, right? So that becomes 3. What am I doing wrong? X plus 1, negative 2x plus 4. Oh, yeah, that's right. Sorry, it's not 1 plus 4, it's 1 minus 4. So that would be minus 3. And really, substitution or graphing, I think, is the best choice here, because now I would have to add 3 over and get, again, that x equals 1. And if I plug 1 back in there to either one of those equations, just like the other options, I get 2. What we really want to think about starting out in this class is, when does it make sense, right? Knowing the 3 options and knowing when it's best to do one or the other. The other 2 examples here are talking about applications, talking about revenue and cost and profit. And so we're going to do those together in class, but maybe you can read through those and see what you think, and we'll pick this back up in class.